Welcome back to Engineering Economics. We are going to continue with examples just getting a little more complex. So in this example, we're going to revisit the one that we just did all together. And the catch then, the difference is that this time we are not going to force the useful lives to be the same. We are going to leave the useful life of machine X at 6 and machine Y at 12. So in this problem it says, create a choice table for machine X and machine Y using an EUAW analysis. Okay, so it tells us to use an equivalent uniform annual worth analysis and to leave the useful life of machine X at 6 years. Okay, so I'm going to rewrite down the data from the example we just did. So I have a machine X, machine Y, and then I have my values this way. So initial cost is 200, uniform annual benefit is 95, salvage value 50, useful life 6, etc. Okay, so now I kind of wrote these in steps. Step 1 is going to be to find the equivalent uniform annual worth for each machine. And I could do this for every single percentage like I have done in the past. However, it tells me the MARR was 10%. And so I'm just going to use 10% to find values. So I know this looks ugly, but stay with me one step at a time. So the equivalent uniform annual worth for machine X, I'm going to write it out here as if I were to use engineering economic factors. Back in the day, before we started using Excel, we would just take our net present worth from one problem and just convert that using a given P formula, right? Or A given P formula to convert from present worth to annual worth. However, since my design life is different, on the previous problem, we forced it to have a design life of 12 years. So my present worth was based off 12 years. So I can't just convert the present worths from the previous sample on this one because my design lives are different. I can do that for machine Y, and we will do it that way in a minute. But for machine X, I have to just full out come up with a new calculation. So I'm going to say then that that's my initial cost that I want to convert to an annual value, plus $95, which is already an annual value, plus $50 times, and then that's going to be a future value because it's a salvage value, so I need to convert that to now, or to an annual value, sorry. Okay, so then I'm going to write that out using Excel formulas. So it would look like this. My payment formula, which is by default negative, so negative payment times I, comma, N, comma, P plus 95, because that's an input, right, an income, minus PMT, and this time I have an IN, and then I have that empty field where the present worth would go, and then I have a future value. Okay, so I'm going to now kind of write out exactly what my calculation will look like, and I'll just write that down here. So this is negative PMT times my interest rate for 6 years, comma, and then negative $200 plus my uniform value minus PMT times my interest rate for 6 years, empty field where the present worth would go, and then $50. And kind of one little thing to note here is that this $50 is an income, so I leave it as positive here. If it were a cost, it would need to be a negative. Okay, so I get $55 as an equivalent uniform annual worth. So one thing to note here is we're looking at worths, not costs. So for an equivalent uniform annual worth, I want that value to be, I want the greatest equivalent uniform annual worth, right? Because it's a positive value. Okay, so now let's move on to for machine Y. So for machine Y, as you can see here, I am just going to take the net present worth we came up in the previous video, and I'm going to convert that to be an annual value or an A value. Okay, so I'm going to do that then by saying negative PMT of my percentage rate of, and this one's going to be 12 years, Okay, and then I want a present worth. So I'm going to go get it. So in the previous example we did, I'm going to find 10% machine Y, and then I will close that percentage. Okay, so my minimum attractive rate of return of 10% will yield an equivalent uniform annual worth for machine Y of $24. So you can see here I have X and I have Y. So at 10%, I mean, it's very obvious that machine X would be making me more money, right? So 55 is greater than 24. So at that percentage rate, my increment would be $31, uh, and this is, I wrote it as y minus x, but then those are backwards. So y minus x would be negative $31. Okay, so next we're going to now move on to learn how to use GoalSeek to help us find where, like, the interest rate where these two are going to be equal. So another way of saying that is we're going to use GoalSeek to help us find the interest rate where my equivalent uniform annual worth is equal for the two machines, even though their design lives are different. Okay, so I have tried setting up this GoalSeek table in many different ways, and this is the best way I have found to do it that works. So I know parts of it are redundant. Just try to reference as many things as possible so you're not rewriting numbers. That's the goal in Excel, right? So I have columns of machine, interest rate, design life, annual amount, initial cost, salvage value, and equivalent uniform annual worth. Okay, so here, all of these, I just put my minimum attractive rate of return. And here I just referenced the values above that I got, so I'm not having to solve them again, just to kind of summarize what's going on. Down here now, I'm calling it a GoalSeek table. You can see this. So for my GoalSeek table, I'm going to set this up with machine X, machine Y, and then my incremental analysis. Okay. So for my interest rate here, I right now have 0. Okay. So you'll notice here, this next one is referencing B46, and then this here is referencing B46 as well. So I'm going to try and solve for this cell. I'm going to have Excel solve for that cell for me, and that is going to, I need that then to be referenced here and here. So I can't have individual interest rates here. They need to all go back to the same one. Okay, so then over here, I just took these formulas I used in my EUAW up above, and I rewrote them here. So I am referencing the I, the N, the A, the cost, the salvage value. Okay, and likewise setting this one up here. Okay, so now I'm going to go into GoalSeek, and once again, the goal in GoalSeek is similar to what we did before by hand with interpolation. I'm in essence setting the one line equal to the other, and I'm just letting Excel do the solving for me. So I go into data, I go into what if analysis, and then GoalSeek. And if you don't have that listed there, you might need to do an Excel add-in for it. So I'm going to set cell, this one, what is this? G48, I'm going to set that equal to 0 because that's my goal, right? I want my increment to be equal to 0. So, and remember, all an increment is the one minus the other. So in essence, what I'm saying is the difference between the one minus the other is going to equal 0, or that means then setting them equal to each other. So the way I do that then is by setting this cell right here. I want to change that. So Excel is going to iterate for me, and it's going to run a ton of calculations and find out at what interest rate makes that cell 0. Okay, so that ran really fast, right? Much faster than I could do it, even by interpolating. So it tells me at an interest rate of 1.32%, okay, these two machines have an equal equivalent uniform annual worth. Okay, so then all I do, and if you remember back from our previous example here, that was the same value. I mean, we said 1.3, this got more accurate at 1.32, but yeah, we get the same answer. Okay, so then for my choice table, I'm going to just say from 0 to 1.32, choose machine Y. From 1.3 to 20, choose machine X. So on one hand, you might be saying, how do we even know if I choose X or Y based on those interest rates? If we came back up here and looked at my 10%, we know, let's maybe come back here. We know that at 10%, the lines are crossing each other, right? So we know that they're crossing each other. We don't necessarily know which one's on top before or after that, but we know they cross each other. So now I can say, okay, look here at 10%. At 10%, machine X had a greater EUAW. Okay, so that means to the right of the 1.32, I would choose machine X. So they cross each other. Now to the right of that intersection point, machine X has a greater value. So that means then before that intersection point, machine Y had a greater value. So that's kind of how I came up with that answer. So that's an introductory video on GoalSeek using the example we did before. We're going to move on now with a different type of problem in GoalSeek.